Continuing to plot, we had our 2, 8. We also have 3, 4. And remember, the order is important on these. We have 5, 2, so 3, 4, 5, and up 2. And we have 9 and 1. So it looks like we have a curve heading that way. And let's see what's happening on the left side of our little dividing line. Later, you learn a little bit more about it, but that's an asymptote. At -1, we're at -4. At -1, 2, 3, we're at -1, 2. And at -7, 7, we're at -1. And that's really all that would end up giving us nice, neat corner points. So again, the red dots would be the graph if we're talking integer domain. The patterns would be the real number domain, as well as just showing us generally what's happening with this graph. So we just connect it up with a smooth curve, and each of these would have a pair of, each part of the two parts of the curve would have a pair of arrows. Now this is one way that a rational function can turn out. There are others though as well, so I can't guarantee you a shape when we're working with rational. It's possible we'll see something like this. It's possible that they'll both be sort of curving in the same direction. It's possible that it actually reduces to a line with a hole in it. There's many, many possibilities for rational functions. All right, so I'm going to have you all try a few of these out. So we'll start with f of x is worth x minus 3 quantity squared minus 2. And a little hint on this one. Start at x equals 3 as the middle. So try out 3, and then go to 2 and 4, then go to 1 and 5, etc. So go ahead and pause and give it a spin. Okay, welcome back. So I'll start with our hint that we start this one at 3. So f of 3, 3 minus 3 quantity squared minus 2, which is 0 squared minus 2, which is 0 minus 2, which is a -2. So our ordered pair then would be 3, -2. As I said, start building out around that. So we'll try up 1, down 1. So up 1 would take us to a 4, down 1 would take us to a 2. F of 4, 4 minus 3, quantity squared minus 2. Order of operations, take care of the grouping symbol first. Exponents and radicals after that. No multiplication, division to worry about. Finish it off with addition, subtraction. So 4, -1 should be on our graph as well. Trying out the 2, f of 2, 2 minus 3 quantity squared minus 2. -1 quantity squared minus 2 is 1 minus 2, which is the same, -1. Going 1 in either direction, we'll have a 5 and a 1 to test out next. F of 5, 5 minus 3 quantity squared minus 2, turns into 2 squared minus 2, 4 minus 2 is a +2, so 5, 2 should be on there. f of 1, 1 minus 3 quantity squared minus 2, negative 2 quantity squared minus 2. Negative 2 times negative 2 is positive 4. Minus 2 is the same, positive 2. So we have 1, 2 on this graph as well. And really one more pair is about all that will likely be able to fit in the negative 10 to 10 grid. So we'll try out the 6 and the 0. So f of 6, 6 minus 3 quantity squared minus 2 is 3 squared minus 2. 9 minus 2 is 7. And hopefully you predicted what this turns into. I'll let you fill that in. And hopefully you discovered that, yes, that indeed should be a 0,7. So if we want a graph, remember a graph is just a picture of ordered pairs that give a true statement in the original. So we have a 3, negative 2. We've got a 4, negative 1. We've got a 2 and a negative 1. We've got a 5, 2. And we've got a 1, 2. We've got a 6, 7. 4, 6, and 7. And we've got a 0, 7 as well. So the red points would be our graph with the integer domain. The blue would be the real number, as well as showing the pattern. Okay, so next up, we'll try out g of x is the square root of the quantity x plus 2. So your goal when you're trying this one with the square root, get a perfect square (0, 1, 4, 9, 16, 25, 36). Remember, those are perfect squares. Get a perfect square under the square root. So I'll give you a start. If I plug in a negative 2 for x, negative 2 plus 2 would give me the 0 that I want there. So I'm going to let you pick it up from there. Go ahead and pause it and see if you can sketch this graph using the point plotting method. Welcome back. So our g of x is square root of the quantity x plus 2. The plus 2 is under the radical. That's one other thing to note. Square root of the quantity x plus 2 does not equal the square root of x. Close it up and add 2. Those are not one and the same. Okay, so g of negative 2, square root of negative 2 plus 2, which is the square root of 0, which is 0. So that's our g of x value, giving us an ordered pair of negative 2, 0. So my next goal was to get a 1 underneath here. Hopefully you figured out that a negative 1 plus 2 would give you a positive 1 underneath. So negative 1, positive 1 is also an ordered pair on our graph. Next up, I was looking to get a 4 underneath. So 2 plus 2 would give me the 4, so I'll plug in a 2 next. So 2, 2 is on our graph. Next up, I want to get a 9 underneath. What did I have to plug in to get that? A 7. 7 and 2 will give me 9. So g of 7, square root of 7 plus 2, which is square root of 9, which is a nice pretty 3. So 7, 3. Next up, to get to 16, I'd have to go all the way to 14. That's off of our negative 10 to 10 grid. So I'll go ahead and call these 4 points sufficient to sketch this graph. So we have a -2, 0. We have a -1, +1. We have a 2, 2. And we have a 7, 3. Oops, my apologies. That's at 8, 3, 7, 3. Now remember, we don't want a negative underneath the square root. -2 gave us a 0 underneath the square root, so anything to the left of -2 would give us the square root of a negative. So in this one, when I'm drawing the pattern, my pattern is only going to go in one direction, not two directions. One other important note with this, make sure you do remember to include what would give you a 0 underneath that square root. The graph is not complete if you start it here at what would give you a 1 underneath. Make sure you finish the graph. So I have, okay, our next one, we'll take a look at sketching the graph of, what did I pick out here? H of x is the absolute value of the sum of x and 4, close it up, and a +1 outside. So the hint on this one, start at x equals -4 and move out. So -4 is going to be your sort of center for this one. And see if you can look back at the previous problem and figure out why I'm giving you the hints to start where I'm telling you to start on these last two problems. Okay, welcome back. So we'll start with an x value of -4. H of x is absolute of the sum of x and 4, close it up, +1. So h of -4, absolute value of the sum of -4 and 4, close it up, +1. So that's absolute of 0 plus 1. 0 plus 1 is worth 1. So that's our h of x value, our output, our dependent variable value. So our ordered pair then is -4, +1. So then we're moving left and right of -4. So moving left will be at -5, moving right will be at -3. So h of -5, absolute of the sum of -5 and +4. Close it up. That should be vertical, not a parenthesis there. +1, so absolute of -1 plus 1. Absolute value of -1 is 1, so we have 1 and 1, which is 2. So -5, +2. Drawing out the -3. Absolute of -3 plus 4. Close it up, +1. Absolute value of +1 plus 1. Absolute value of +1 is +1. 1 and 1 is the same output we had before of 2. So -3, 2 should be on your graph. So we'll do one more pair of these, and then we'll try to discern the pattern emerging. So we'll try a -6 as well as a -2. So again, we're just moving one more unit away from our center. So h of -6, absolute value of -6, close it up, +4, close that up, +1. Absolute value of -2 plus 1 is 2 plus 1, which is 3. So -6, 3. And h of -2, hopefully you noticed, gave us the same output of +3. So absolute value of +2 plus 1, but the absolute value of +2 is still +2. 2 and 1 is the promised 3. So hopefully you notice that in the problems where I gave you the hint of where to start at and move out, it was what value would give you a 0 in the middle. So absolute of 0. The other problem we had 0 squared, and then moved out from there. So let's see. So we have -4, +1. We had -5, +2, and we had -3, +2. We had -6, +3, and we had -2, +3. So this pattern would continue. Going this way, we will just keep going up 1 and right 1. And that's part of why we draw graphs. If you take any of these ordered pairs that I just plotted in here, plug it into the original, you will get a true statement. So for example, here we have, well, let's do the 1. 1 is paired with an output of 1, 2, 3, 4, 5, 6. So we're predicted to get a 6 out of this if I plug in a 1. 1 and 4 is 5. Absolute value of 5 is 5. 5 and 1. Sure enough, output of 6, right where that dot is. So the dots will go up 1 and left 1, going in this direction. And again, if you're doing these absolute value graphs and you're not finding a bounce, either look for where your center should be, or if you can't remember exactly how to do that, keep testing some points until you find some of the points start going in another direction. An absolute value of a variable will never give you just a plain linear graph. All right, so that should give you enough to play with for, this was section 3.3, so try out the 3.3 exercises. And remember, those are at the back of the chapter 3, not at the end of the section 3.3. You have to go to the back of the chapter to find those. If you have any questions, please get in touch. Otherwise, I will see you next time. Stay safe out there.